Hello everyone again to my YouTube channel. Today in this session, I will share with you a small project on EDA for exploratory data analysis. Because as we know, in any project of machine learning or in data science, we have a life cycle of projects. Well, today I will explain for you or share with you some tricks, some techniques to analyzing our data using a famous dataset, Zomato dataset. Okay, Zomato dataset is available for everyone interested to discover this uh, dataset. Well, exploratory data analysis is maybe have a weight of 30% of any project of data science because in this phase of EDA, we try to understand deeply our data before try sorry for trying to make any decision. Okay, we need firstly understand our data, and this time we can building or try to predict or perspective sometimes. Well, in the analysis we have a lot of type of analysis. We can have we can have causal analysis. We can also face in descriptive analysis, perspective analysis, predictive analysis. Okay, but in this we have also exploratory analysis or exploratory data analysis. So in this phase we cannot just try to discover some things based on this data we have. Well, I work in the collab, okay, Google collab, because this data need much of resources to run it. Okay, well, here the most step I do here is to import all the packages I can need here in my data analysis. Well, I import MATLAB Lib for visualization, NumPy for some conversion if we can do that conversion. Okay, we have also Seaborn for visualization, for statistical visualization. Okay, we have also Pandas for to convert our data to uh, data frame. Well, this is all the packages I need for now. Okay. Well, the second step is to load our data. Okay. Here we have this Zomato CSV here as we look in this folder of simple data. Okay. I loaded here. Well, this is the path, the content sample data Zomato CSV. I try to encode in all Latin because it's not possible to read it with this function directly. We need to make some encoding, and we have a lot of encoding, and we can also facing these problems of the data not reading just when using this simple function. We need to make some encoding here. Well, I store my data frame in this variable called def, and I just to return 5 and records. Okay, here I using this head function. So will I run it? I run my data, and this is the data we have here. We have some columns here. We have restaurant ID, we have restaurant name, country ID, we have the city, we have address, we have locality, we have locality purpose, longitude, latitude, cousin, currency, and has a table working. Okay, this is all the feature or the variable we have for now. Clear in this, but we can see the other ones because we are not show all the features or the variables we have here in this data frame. Well, we have also a famous function attribute. Sorry, called shape. This shape function or attribute give us the ability to discover the shape of our data set. Here in our case, we have 9,000, around 9,000 record, and we have 21 feature or 21 variable. Okay, okay, let's continue. Also, we have another file with Excel file. Let me see here. So I load it also. Okay, I try to discover the content of Excel file. I use the same things. I create a variable and I call this function of read Excel because the extension of this file is Excel. For this reason, I need this read Excel function. And also, I put the path of my file here, and I read it, and I use this head function to return for me just first five records. Well, the content of this file is the country ID and the name of country. As we see, we have country code and we have the country here or the name of country. Okay, we have one and here we have Exploratory and so on. Well, if we turn to our data frame, principal data frame, we look here, we have the code country. Okay, we have here this feature or this variable called country code. Well, also in this file of Excel, we have the same name or the same feature or the same variable. That's called also country ID. That means we have the ability to merge both files. Okay, we can merge both of files because we have the common ID or the common country or the common columns here. That means we can merge both the data because in the principal data frame we don't have the countries. Okay, the countries does not exist in our data frame. To show you, it's creating another df dot columns. Well, if I run this data frame, if we check all the name of the variables or the columns we have here, we don't have the country. Country is not exist. So for this reason, we need to merge both of the cells or both of the files to add in the countries here in our data frame. Okay. Well, this is what's happened. Well, I create another variable. I call it new df, and I apply the merge function pd pandas dot merge, and I put here the principal data frame I have df, and also I add in the name of the other variable or the other file we have here, and I have here the attribute. That means how we can do that because me personally I concentrate or I interested with this principal data frame. For the reason I called a lift. Like I interested with the lift table or the lift data frame here. We can write in the right if I interested with the lift. But for now I interested with lift data frame. For this reason in this attribute I assign this value of lift. We have also this on attribute. The on attribute is only what is the columns I need. Based on this column, I can merge our data as I show you before. We have the common columns here called country code. When if I run it, I get those results here. Okay, and if I check, I have 22 columns, but before, sorry, if I return to my principal data frame, we have here 21 before adding the new column of countries. Okay, here we have 22 columns. That means we add in the name of countries. Well, the second or the next step here is to check the null values. Okay, for any data set, we can have sorry, we can have unknown values. Okay, let me add it colon here. So to check unknown values, we can adjust using this nil is nil function. But for me here in this case, I put it as a percentage. But in the original, we can use new df out is nil. So that means here I need to check if my data set is nil or well. If we look here, we need to I apply here the is nil function on top of my data frame here, and I want to sum all the nil values. So as we see here in our columns, we have 0 in the return ID. It does mean we have any non-value here, and we check the other columns here, but in the cousin we have 9 missing value. So in the cousin we have missing value. In the other columns here we have 0 0 for all. That means we don't have any non-value. But in the cousins we have 9. Well, if we return to this code, that's what I do here. But I try to convert it to percentage. Here, new df is nil to sum divided by length of all divided by the length of all these columns we have here, time it in 100 to make it in the percentage. Okay, I make it to percentage just to see how much of null values in the percentage I have in all this my data set. So for this reason I make it as a percentage. See the same things, okay? Here the 9 I make it as a percentage. That's what I do before. So let's continue. Here in this piece of code, I apply this piece of code just to make my figures more clear. With pyplot, we have this arrays params, okay, arrays params function. I pass the figure and I apply fixed size and I pass this value just to make my figures more clear. That's what you do. Okay. Well, here we have another syntax to check if we have the null values, but this time with list comprehensions. Everyone interested to know what is the mean list comprehensions can be go to my playlist of Python. Okay. Well, I store the null values inside of the list. So that's what I do. Well, I create a variable called feature for feature. Feature does mean here the variable I use to iterate inside of these columns of my data frame. So feature for feature in a new DF or new data frame, that's columns. I enter it just in my columns. And I will verify this condition I put here. If the new DF, the feature that I mean, is nil, and sum of all this value near is more than 0, I will put it inside of my list. Okay, if I run, this is the result what I get. And if we check before the cousin, we have 9 non-value in the cousins or in this column of cousins. Okay, well, also we have the ability to using some visualization techniques to discover the non-values. This time I use is as means seaborn, is seaborn dot heatmap, the heatmap. Okay, is dot heatmap. I pass this value here. This new df dot nil is nil. That means I interested with just nil values. For y labels, I assign this value false value because I'm not interested in this y axis. And we have c bar also, it's false, it will be false because I'm not interested. But in this cmap I pass this value of cvds. If we check the documentation of cborn, we can have found a lot of values with the cmap. We can also be plasma, or we have a lot. Okay, someone is interested to know the values we gonna pass for or we can assign for this CMAP, we can check the documentation. Well, this is the result I take it. Here in this x-axis in the bottom, we have the name of my columns of my data frame. And if we look here, we have a small dot, yellow dot here. That means in the column we have the non-values here. Okay, but then why we don't have how much of the non-value we have here? Just we mentioned visually, we have non-values here with this dot, yellow dot here. Okay, well, let's continue. Here also we have this attribute of columns to check or to see all the values we have here. As I show you before, when I call this column function, the columns of country is not exist, but for now with this new div is exist here in this data frame. Okay, let's continue. Also, we have an important function called info. So the role of this info is give us some information about my columns. We have also the information we can provide it by this function is the name of column, the name of all the columns I have in my dataset, and also the number of column here not nil. If we check the number here, so all the numbers here is the same except this column we have this number. Okay, and also the information provided by this function is data type. Okay, each variable has its own data type. If we check in the restaurant ID, for example, we have integer 64. That means the type of this restaurant ID is 40 or integer 64. The restaurant name is object. As we know, the types or data types for uh, or the data type we have in Python, each or everything is considered like object. Okay, but we can transform it based on based on the syntax we have, or that's based on what we want. Okay, well, the restaurant name here is object. Okay, the restaurant name is a string, that's but it's considered like object. Also, the country code here is considered like integer 64. You have city is considered object. Okay, but object here can be integer, can be string. Okay, sometimes we can face in some columns of dates. Okay, in the most of time it's considered like an object, but we need to transform it to that time to work with in our analysis. Here we have longitude is a float 64, latitude also is float 64, and coordinate is object. That's mean here in this information function we see the type of our data also, and we can see the none, or we have some missing value here, and the name of all the columns I have in my data frame. Okay, let's continue. Also, we have basic function called describe. Describe function is just for descriptive analysis. That means statistic. Descriptive analysis does mean statistic analysis. Well, in describe, just work with just the numerical columns. If we check here, all these columns here is numerical. Okay, we have restaurant ID, we have country code, we have latitude, average cost for two, price range, aggregate rating, and the votes. Well, let's work only with the numerical values. Here, if we check, we have this restaurant ID. That means it's not meaningful. Also, the country code is not meaningful. Okay. Latitude, we can use it just for any map to visualize. Okay. Uh, some localization. But if we go to average cost for two, we can extract some information. So average cost for does mean the cost of two. food maybe or something like that. We have the mean. First we have this function of cost count. Sorry, the count does mean number of all the records I have in my dataset. And also we have this function mean, which here this is the mean in this or the mean for this column here. And also we have standard deviation. So if we look, we have high standard deviation in this dataset, and we have the mean here. We have the minimum is 0, and we have 25% of data. We have 2000 or 250. Okay, 250 just for 20% of my dataset has this number. And we have also the median. This means 50% is 400. So if we compare between the median and the mean, we have a difference. This difference is clear. Okay, that means here the center of data it's in the left. That means it's not normally distributed, or because we have the outliers. Have outliers for this reason. The mean is big compared to the median here. And we have also 75% of data has this number of 700. Okay. Also the same things for watts here with we check. We have here the average is 1060, 1056, and also here for the average or the median we have just 31. The difference here also it's clear. The center of data is in the right, in the left side. Okay, maybe we have some outliers here. Okay, so this is the role of this discrete function give us some idea about my variables and my features. Okay, that's some of the derivation I have here. The mean here for the cost average is more than median. Maybe because we have a lot of outliers or something like that. The same thing for both feature. We have the mean here is with this value, and the median is least is very least compared to the mean here. Maybe because we have outliers, something like that, or something like that. Well, here I check all the countries I have in my dataset. To do this, I apply this value count function on top of this column country. Well, new df I trace just country. I am interested just for column country. Then I apply this function of value count, and I get the result here. We have India, we have United States, United Kingdom, Brazil, UAE, South Africa, New Zealand, Turkey, Israel, Philippines, Indonesia, Singapore, Qatar, Sri Lanka, and Canada. So this is all the countries we have in my dataset. And the top one here is the India. Okay. That means the first idea we can extract from this data, the most transaction we have here in this dataset is India. Is in the India. Okay. Well, let's continue. So here I try to show the weight or the contribution of the India in this dataset. That means how much of percentage or the percentage of the contribution of the India in this dataset. Well, I apply this round function just for give me the number after the comma. Well, here as we see, we tracing just two numbers. I apply here the max function on top of this new df country value count. I want to count all the value we have here, dividing on the sum. Okay, on the sum of this, all the values I have here. So here I apply the max on top of this. Here I apply the sum on top of this, the same expression. UDF, I trace in the country in my data frame, and I apply this function of value counts. And I time it for 100 to make it just a percentage. And this is the result here. We have 90% of all the transaction here just in India. Okay, that means the Zomato is in India. this transaction on Zomato happened in India. Well, also I bought this number of 435 because is in US, because the next country coming after the India is United States. US, United States. Okay, so for the reason I check the percentage of contribution of United States here. Okay, it's 4% is weak number compared to India. Well, let's continue. I chose to using the pie chart here. The pie chart we use it to show the composition, because in the tools of visualization we have the composition, we have the distribution, we have the trend also if we want to check the trend is on time or something like that. We have also the correlation to check in the relationship between variables. So, but here in this project, I choose to work with a pie chart just to see the composition of my data. Here, what I do, I create the first variables called names country. Okay, name country equal to df. I choose country here, dot value, and I choose the index of these countries. And second values or the second variable here is the values of country. New df country value count. I choose the values of these countries. Well, I applied PLT, I plot, okay, PLT, matplotlib, plt.py chart. I pass these values country here. I choose just top five or top four. Okay, I choose here just for I'm interested just with top five. Also in these labels of or also in this attribute of labels, I pass just for, and I apply the percentage to see the composition, and I give the title of this pie chart. When I run it, I get this result. So the most of composition here is, or the most contribution is in India, and we have United States and United Kingdom, and also the Brazil. Okay, with this percentage we have. Well, let's continue. Here I using this package, or this this package of volume package is for mapping. Okay, we have for map to visualizing some coordinate or something like that. So I apply it here, but I don't use it here because that's taking time to run it. So for this reason I will show you the picture here. Sorry. Well, so this is the, I using the volume, and this is the result what I get here. This is the coordinate. This is, I using this longitude and latitude and longitude we have in the dataset to visualize or to make in this map. It's easy. I don't use it in my notebook because it's taking time to load all the data we have. So this is the coordinate of all the restaurants we have. So if we look here, the most of restaurant is in the Asia continent. That's mean in India especially. Okay, the most of restaurant here is this in India. Okay, well, it's good here. I use this center. Okay, I give it this coordinate. Then I map this volume.map location center and zoom starting from 0 and zoom in start from 0, and I apply the loop here for ENG in my dataset new DF on my data frame here. I enter all rows I have I wanted in this location. I store this location here for longitude and longitude. Okay, well, I apply this volume marker, okay, to make this one here, this point here, this marker, okay, for to make me the map is clear. Well, location, I pass the location here and pop up for this new DF for the city, and I add it to my map. And if I want to call this next, I can just using map. Okay, map. I run it and they get the same picture, but taking time to load it. So for the reason I avoid it, I have taken just a picture for this map. Well, let's continue here because Zomato or 90% of all the transaction we have in Zomato is in India. To choose the India, I use in this filter with the centers new DF, new DF inside also. I specify the country or the column of country here, and I pass this value of India, and I return for me just the India data set here. Okay, we have this number 8,000. All the records we have just for India. Okay, also in India, because here if we check in the data, we have also we have the city column here. Okay, we have the cities. That means I want to see the cities on India we have in this data set, and to do that we can use this syntax. Well, new DF, new DF country. I pass the India, and they want also the cities, and they want to count values of the cities we have in this dataset. So, and I run my code. This is the result I get here. We have New Delhi, 5,000. We have Gorian, Noida, Fardidat, Ghaziabad, Ahmedabad, Kamita. We have Po, we have Nashik, Nagpur, Mysore, Mumbai. So we have all the cities in this dataset. Okay, said cities in India. Well, in New Delhi is the top one. Okay, in New Delhi is the top one here. Well, I go and I see the max. Okay, here new DF. I store the India. I choose or I group by this city, and they want just the max one. So this is the same syntax. I get the same result. If I want to use this or this, here I use in this value count, and also here we can group by city, and they will get the same result. Okay. I want just the top one here with this number of 5,000. So 5,000 is here with New Delhi. That means the city or the most of transaction we have is in New Delhi city. Okay. Well, so I want just to measure the weight of the contribution of New Delhi of based on this data set we have here. We have the India, all the transaction we have in India is 80,000, and in New Delhi just we have 500, and the percentage of contribution of New Delhi is 60, 63, 63 4, 60. So it's not clear for me. It's 63%. Maybe it's 46% just for all this transaction. It's happened in New Delhi. Okay. Well, we are also interested of uh, this rating. So to show you rating here. Well, again, this PDF dot columns. So this is the columns we have here. I chosen this rating text because here we have a rating, aggregate rating, rating color, and rating text. Here in our dataset we have the ratings. So if we go Well, so that is not clear in my dataset. Okay, well, oh, I will just show you the values we have in this rate, but that's will be clear. Okay. Well, here I chose this rating text. That means all the text we have in this rating, we have average, we have excellent, we have good, we have not related, we have poor, we have very good. This is the values we have in this rating text. This is all the values we have. Well, our role here is to count the number of each of these rating text here, just for New Delhi, because my purpose here is to know why all these transactions happen in New Delhi just. Okay. Well, I count the number of rating text here for each mm, comment or the text we have here. The average is the most one here. If we see, is the top one is average. Okay, and we have excellent, we have good, and we have not rated, and we have poor and very good. Well, I I I, I take all this value here and I pass it to in separate list. In Delhi, I pass this value here. I take in this value, I pass it here, and they take in also the name or the index of all these written texts here. I pass it here, and I apply the bar plot just to see what is the most frequent value here. So in this plt.bar, I have text DLE, okay, text DLE here, and we have also DLE the number or the list of numbers and the weights of these bars. If I pass it 0.4. Well, I give a title for this is a rating text. Well, this is the result what I get here. So in this bar plot show for us the most frequent value here. Okay, we have average is the most frequent one, and the second one is not rated, and third is good. Okay, most frequent is average. So frequented maybe is 2000 times. Okay, well, also I propose some observation about causal analysis why we have the most transaction is in New Delhi city. Also, the first thing is the region of average is between 2.5 and 3.4, and they will see that after. Also, we have the population in Delhi or in New Delhi is around 32 billion people. That means we have high density of people. For this reason, that can explain for us why the most of restaurant is concentrated in New Delhi. Also, we have the location average in India salary. Okay, we have the average salary in India, in Delhi, in New Delhi especially, is 41,000 rupee. That means it's $500 with the United States dollar. It's 553. Okay, that means it's a high average salary based or compared to other cities. Also, because with this high density of population and this average salary, that means we don't have much of time to cook in home. For the reason we go to the fast food or go to a restaurant to eat. Well, is maybe some reasons or some factors can explain for us why this high production of Zomato is happening in New Delhi. Okay, so we count also the number of the city we have in this dataset is 43 city. 43 city is exist in this dataset here. But the most one is New Delhi, or top one is New Delhi. Well, let's continue. Also here I create a new data frame based on three columns we have. I mentioned that before. We have aggregate rating, aggregate color, and aggregate text. All these three columns is exist in our data frame. Okay, I grouped by I apply this new the DF or new data frame, and I grouped my data set based on these three columns we have here. Okay, and I reset index. Okay, I use this to return the results, and I rename this column 0 because when I run my code here, this will be returned as a 0, but for me I want to change the name of this column from 0 to rating counts. Well, this is the results. This is ratings, and this is the result I take it here. We have rating aggregate. This is the indexes here, the values, and we have also the rating color. The first one with 0 rating is with weight color and is not related. The rating text is not related, and we have the number of not related is most one is the most big one here. We have 2000, around 2000, and we have also 1.8 is a red color with poor rating text is poor, and the rate count is just one. And also we have here all these indexes and with these colors here with the red one. So from 1.8 to 2.4 is for the poor one. So each restaurant has this indexes poor with this red color, and from 2.5 to 3.4 is orange one. That means is average. Okay, this is the number of all these things, and from 3.5 to 3.9 is yellow and is good, and from 4 to 4.4 it's very good and it is green color, and from 4.5 to 4.7 is dark gray, and that means it's excellent, and this is the number of restaurant has this rating. Well, what is the goal or the purpose here is to visualize all these ratings here, and to do that I apply with Seaboard is an instance bar plot. I apply this bar plot, and in X I pass this aggregate rating. I trace just aggregate rating here. This indexes. Okay, I trace it indexes in X axis against Y rating or rating counts here. That means how much of or how much is it's frequent. Okay, and I take in both uh, features or both variables from this data. That's mean ratings. The source of this data x and y is data is ratings, and this is the result to take it here. Okay, if we look here, we have this color of orange color here. It's with 0 ratings. It's most frequent, and we have the other ones here in this distribution. Well, I passed the colors. Okay, I add in this attribute of palette. I pass this color here. We have the weight color because it's not clear. So for the reason I chose this purple color here to make it. Okay, the same things here. I make it with this purple color. We have also red one. We have orange. We have yellow. We have green and green dark. Okay, this is what we have here. This is with color distribution or this visualization based on this color we have. Okay. Well, as observation here, if we look out of visualization, we have here and here in the purple color. That means the most not related is more high because the most related is with index of or with value of 0.0. So this purple color or this not related is more high or more frequent. Okay, that means the people is not geared to rating some restart. Well, the second observation I have here is the maximum number of rating is between 2.5 and 3.4, and that will be clear for us when we try to count in the number of color. Okay, That's what you see here. Also here in this seaborn, I apply this function of count plots. You have rating color. I trace this time the rating color. That means I want to count the number of color here. And I take in this data from these ranks ratings data, and they pass those colors here with palette. Well, the result is here. The orange one is the most frequent. So for this reason, if we check the orange one here, is the maximum one. Why I tell you in this observation is the maximum one? Because this index or the values we have here in this range of rating, we have it between 0.5 and 3.4. It's most frequent one here. And in this visualization with count plot, show for us this. We have the orange one and the second one is red. That means it's not the red one here. And wait here. Okay. Wait. Okay, just I want to count the number of color. I am considerate or I'm interested in the number of color, the number of color. We have 10 times here. Okay, if we counted 10 times, if we check our data here, that will be clear. If we count in the number of range here, it will be 10. Also here in the yellow, we have 1, 2, 3, 4, 5. Yellow color, if we go here, yellow color here is 5. Okay, this is 5 here. Well, let's continue. If I want to ask some questions based on this data, for example, if I want just to see the name of countries has 0 rating, that means it's not rated. Well, I will create this piece of code. New df or new data frame. New df is I choose this aggregating rating. That means I'm considering with this value of 0.0 here. Aggregating rating here is 0. I filtering here, and I want to group by country. I want to group by country here. I using this size to return the values, and we have raised indexes here. Okay, and we have here the country, and we have here 0 here. I don't want try to rename it, and here I'm writing anything here to just drop on this 0 and replace it with some other name, but it's okay. Well, we have here country. We have Brazil, we have India, we have United Kingdom and United States, and we have the number of uh, most uh, most of the aggregate rating is 0. That means the most of restaurant is not rated, is not related, is in India here. As we see in India, we have this 2000, around 2000 restaurant is not rated, related. Okay. Well, also here we can use this syntax to return for us all the aggregate rating, but here I consider it the 0 rating. That's mean with 0 value, but here I enter it on all this nice we have. If we check in the code here, we have the new df group by aggregate rating with country size with the index, also same things, but here at this time I apply all these the rating values we have. For 0 we have this, and in India, or the number of restaurants have this index of 1.8 is 1 in India. The number of with 0. Or 4.9 here is Sri Lanka is 1, and so on. Okay, well, let's continue. So as observation, as I said before, the number of not related restaurant is in India. That means the number of restaurant has 0 rating is in India. Well, if I want to ask another question here, what is or which currency we have in each country? That means what is the currency of each country we have here? I can also choose in new df dot group by. I want to group by the currency because have this currency as a column. Then I apply this function of size. Then I use it is indexes, and I try to rename the 0 here columns. I apply it or I replace it with count name. Well, we have the Botswana dollar. we have Brazilian real, we have dollar, we have Emirat dirham, we have Indian rupee, Indonesian riba, New Zealand's pounds, we have Qatari riyal, we have also rand, and we have Sri Lanka rupee, and we have Turkish lira. This is all the currency we have in this data sheet here, and the most one also is in India. That's mean because most of this transaction happen in India. That means it's totally normal to pay this transaction with rupee or Indian rupee. Well, let's continue also here. So here, just this function to show for us all the columns we have. Well, I apply this for treating some other columns here to ask some questions. Well, if I want other questions here, how much of online delivery we have in each country? That means here if we check our data set, I have this name of has online delivery. That means gonna have online delivery or offline delivery. Well, to know how much of online delivery we have in each country, I use this piece of code. We have new df group by has online delivery. Also, I group by country because I'm interested to delivery in each country. I apply also this size and I raise these indexes. Well, this is the response or this is the result. Make it here. We have has online delivery now. In Australia we have 24. In Brazil we have 60. Canada 4. And India we have around 6,000. No, that means no online delivery. Everything it's happening in offline. Okay, we have offline delivery. And the most one here is in India. Is the logic. So the most of frequent or most Zomato does it here is happening in India. So it's normally to have this no delivery or offline delivery in India. Okay, and this is all in these other countries. And also we have has online delivery. Yes, in India we have around 2,000, and in UAE we have 28. Okay, well, to visualize this to make it more clear, I use this pie chart to make or to see the composition of these online and offline. Well, I store online delivery as a values and indexes. Okay, I put it here, plt.py, and online value here. This online value I put it here, and labels I put these indexes and I apply auto PACT. That means the percentage, and I give it as a title online and offline delivery. Well, this is the result. The most of frequent maybe is 74% is not or is off. Sorry, 74% is online delivery, and we have 24 or 25% is online delivery. And as observation, if we are return to this, we have the delivery, we have online delivery, we have just in India and in UAE country. Well, let's continue with this. If we check in, I try to check in the table booking. We have reservation of tables here because this this column is existing on my data set. So I ask this question. I try to check in the table booking here. UDF group by has a table booking, country, style, visit, index, and this is the result here. Has a table booking here? No. In Australia, 24% has not. And in India, we have the most one here, 7,000 here. Restaurant is not has not table booking, has not table booking here. Okay, and we have Philippines, Indonesia, all these number here. And yes, we have a number, or we have a booking table in India. We have 1,000 and Philippines and Qatar, and we have in South Africa too, and so on. So here is some basic questions we can ask based on this data. I will see these things which happen line and with no booking table. That's mean everything it's happen. Okay, so without any preparation before. That means okay. Well, um, so here we have 7,000 restaurant has no table booking in India, most one. And also I go to cousin to see the cousins. Okay, the number of cousins we have here. So new DF cousins dot count value and North Indian is the most one here, it's most frequent here. So because the most of transactions happen in India happen in New Delhi, that means those people is like North Indian cousin. Maybe this is secret. Well, if we go also here, I store these cousin values to see the composition. Cousins value here in df dot cousins dot value count dot values. Cousin index in UDF dot cousins dot value counts dot index. Store these indexes in these values. Well, here I apply this pie chart. I just want five top, okay, five top cousins here. Cousins value of five, labels cousin index is five. I apply the percentage to see the composition, and this is top five cousins. Okay, this is what you see here. So uh, the most one here is the North Indian cousins, and we have also North Indian and Chinese, and we have Chinese here and fast food, and North Indian and Mughali. Okay, this is the most or the top five cousins we have here in this data set. Well, also I want to check how is delivery now because I have this column in my data set is delivery now. Okay, I will show you. I go yeah, we have this name of columns here is delivery now. That means I want to see how much or is delivery now or is not. Well, just I apply this pie chart to see the composition again. It's very important. And we have a 9% of all delivery we have or delivery we have is not happen now. That means no. And we have 0 or 0.36% or point 6 1360% is yes. That means it's delivery is happen now is with little percentage with little contribution because maybe we have a lot of people. Okay, we have a lot of people, so to prepare each uh, consummation that it will be taking a time. Okay, so I hope that is clear for you. That's I share with you this basic analysis. Maybe we can do based on that. We can include other information. Okay, to explain why that's happened in New Delhi especially. Maybe we can ask some questions why. Okay, firstly, I give you some reasons, some factors to explain why that's happened. Maybe that's related to average salary we have in New Delhi. Maybe the high density, maybe around 62 or 32%, 30 million, 32 million people. That's mean high density. Maybe you can include other factors. Well, I hope that is clear for you. See you again in my next tutorial. Well, I will put this notebook in my GitHub link in description. Happy learning for everyone again. See you again. Bye bye.